Hi everyone. In this video I'm going to show you how to do a one-way ANOVA real quick. And I just opened up JASP and then I went to open recent files and opened up the stats practice data. And it brought up all of these variables here. And I went here and said, let's do an ANOVA. And so here's where we do the ANOVA. We need a dependent variable. And the dependent variable has to be a continuous variable, so something measured on an interval ratio scale. So let's use English grade for that. And then I'm going to compare kids who are first, second, or third generation US in the US. So this wave 1, wave 3 immigrant variable means first generation is kids who were born outside of the US and then moved here. Second generation is kids who were born in the US but have at least one parent who was born outside of the US and then moved here. And then third generation is parents who were born in the US kids were born in the US and both of their parents were born in the US, or whichever parent they is their primary caregiver. So let's make that our independent variable, what's known in JASP as the fix factor. And we want descriptive statistics, we want estimates of effect size, and this is what we get. So what we see here is that generational status, this is our independent variable, has produced a significant F value. That's statistically significant. And what this tells us is that somewhere there's a difference between these three group means. So I've got three samples, first, second, and third gen, and these sample means are significantly different. The difference between these sample means did not occur by chance. Somewhere there's a difference in the population means. Now, we don't know which means differ from each other yet. We need to do a post hoc analysis for that. But just by looking at them, I can see the first and second gen means are pretty similar, and third gen is substantially lower. So think about this. First generation kids are getting better grades in their English class, even though these kids were more likely to have grown up speaking a language other than English. They're still getting better grades in their English class than third generation kids are. So there's a lot of research out there about why this might be, but this is a very consistent finding that third generation kids often have worse grades than first and second generation kids. And that's what we find in this data set as well. Notice that this F value right there is produced by dividing the mean square between groups, which is this top number, divided by the mean square within groups, also known as the mean square error. And if you divide this top number by this bottom number, you get this F value, which is statistically significant. Also notice that this eta squared, this is an eta squared is 0.036. You interpret this is the effect size, and you interpret this as a percentage of variance explained. So what this tells us is that the variance in our dependent variable, which is grade in English, 3.6% of that variance can be explained by knowing which generational group kids are in. Okay, now we need post hoc tests. So you click on post hoc, you click on this and you move it over, and it gives you your post hoc results to tell us which groups are significantly different from which other groups. And as we kind of guessed by looking at these means up here, third generation students are significantly different from second generation students. They're also significantly different from first generation students, but there's no difference between second and first generation students in their grades in English. So that's how you run a one-way ANOVA in JASP and interpret the output.